All right, let me just show a little picture first of all. If this, I'm purposely not making it, made a little grid here. It may be hard to see, but I made this 5 by 4. And if I made that 5 by 4, looking at the rectangular prism, and then I said, well, how tall is it? And for now, we'll just make that 1 unit. So if I just kind of looked here at one of these things, it's hard to see here, but you would end up with basically 20 little cubes that were sitting here on the bottom of this. That's a really bad drawing, but you understand that if I wanted to put little cubic inches for example, little inches that were 1 cube by 1 cube by 1 cube, I could fit on the base 20 of them. Does that make sense? Everybody with me on that? Now the question is, how high can I stack them? So the next question is, what's the height? Let's make our height 1, 2, 3, 4, 5. If the height was 5, and I could stack 5 of those layers of 20 on there, you would say, well, if I took 20 times 5, that should tell me what the volume is. Volume is just a way of saying how much does something hold. Everybody with me so far? And so with that concept being, what did I do to get the 5 by 4? To get the 5 times 4, that was really just the area of the base, correct? And so when I put a capital B here for area of the base, that's what I find first. And then what did I do? I said, well, how high could I stack it? That's times the height. So the area of the base times the height is simply the way that we find the volume of any prism. Now this is a rectangular prism, but it'd be the same thing here. I could find the area of the base, which in this case would be a triangle, remember, and then multiply it by the height, and that's still going to be the volume of a triangular prism, or any prism at all. For the volume then of a cylinder, it's the same idea. I need to find the volume of the area of the base, but if you wanted to write it in terms of a circle, that's pi r squared. And then we multiply that times the height. So it's still the same formula, the area of the base times the height. So basically, for all of these formulas, for prisms and cylinders, you're using the same area. This is kind of the generic areas over here for the prisms. And then if it's a cylinder, we converted perimeter or area of the base into the proper formula for circumference or area of a circle. But you could have just written it this way too and realized what you're finding the areas of or the perimeters. Is everybody with me? So let's look at an example then out of your work today. I want to look at 3 examples today. We'll look at 3. We'll start at number 6 because your work today is going to come out of 10-5. And we'll start with number 6. And I chose number 6 for a reason. Number 6 looks kind of like this. It's a cylinder, but it's not a cylinder that is what we call a right cylinder. It's a oblique cylinder. This goes into a question that Anwisha asked us the other day, and I said that we wouldn't worry about that right now in terms of areas, but we will worry about it in terms of volume. And it tells us that the diameter of this is 8 centimeters. Now, we could certainly, by the way, that makes the radius 4, does it not? Now, to find the volume of this, we're going to use the exact formula we just talked about. We're going to say, what's the area of the base? Pi times 4 squared. What's the height? And the height is always, when we use the letter H, the perpendicular height. Just like it was in a pyramid, we had something different for a slant height. We used L for that. In this case, the height's always perpendicular, and that becomes a 12. So when you see something that is what we would call oblique, or kind of slanted, the volume formula still works. However, make sure that you're using the vertical height or the height that's perpendicular to the horizontal or to the ground as you solve these. So this is fairly simple. It says to the nearest tenth. So I can hit second function pi times 4 squared, or 16 times 12, and I get about 603.2, and that would be centimeters cubed. Make sure that, I'll move the people out of the way so you can see it. Make sure that we understand that volume is going to be in cubic units. Why? Well, look, we have centimeters times centimeters here, times centimeters again here. So we had centimeters multiplied in that 3 times. So centimeters cubed. And that makes sense because we're talking about how many little cubes, how many little centimeters that are cubed by, that are 1 by 1 by 1 centimeter could we fit inside of this cylinder. Obviously, we would have to cut pieces up and throw them in there, but how many cubes do we start and then throw them up and cut them up and do it? Example number 2. Let's look at a question like number 8. Something like this. 3, 3, 9, 3. Those are all feet. Remember that the first thing, we've always been talking about this, when I look at a prism, is identify the bases. There's always 2, and they're going to be in parallel planes, and they're going to be congruent to each other. If I went back and looked at this one, obviously in a cylinder, the circles were the 2 bases. In this case, the 2 bases are the 2 triangles, even though it's lying on a lateral face. So the bases are still the triangles. So I have to find the area of those triangles. And so these are equilateral triangles, 3, 3, 3, I see that. And if it helps you, draw a picture, draw the triangle out here, make that a 3, drop that altitude, make that a 1.5 and a 1.5. And if you remember, then this is going to be 1.5 times the square root of 3 because this was a 60-degree angle. So this was that you turn that into 2 30, 60, 90 triangles. So when I go to find the volume of this, I have to find the area of the base, which is a triangle, 1/2 times 3, 3 is the base, times 1.5 square roots of 3. That is the area of the base. The height, of course, is just 9. Now, that's not the only way you could have figured it out. You could have done Heron's formula if you want to. It takes longer. But you could have said, well, 3 plus 3 plus 3 is 9. So the semi-perimeter is 4.5, half of 9. And then this whole thing right here could have been also the square root of 4.5 times 4.5 minus 3, which is 1.5 3 times. So these 2 things would be the same. So depending whether you used Heron's formula or the traditional 1/2 base times height, you'll get the same answer. So let's try it out. It says to the nearest whole number this time. So I'm going to use the top one. 0.5 times 3 times 1.5 times 3 to the 0.5 power times 9. Hope I punch that all in right. And I get about 35. I'll go back and look at my units. My units are feet. So this is feet cubed, cubic feet. If you want to check and see if you get the same answer here, let's do it. 4.5 times 1.5 to the 3rd power equals that. If I take that to the 0.5 power, because I have to take the square root of it, I get that. And if I multiply it by 9, I hope I get about 30. Yep, I did. All right. So Heron's formula worked pretty well there. I got about 35 feet cubed in that case as well. Finally, we're going to look at number 13 as an example. And we're also going to look at 14 because I'm not going to show you how to do it. I'm going to give you a couple bonus points if you can get this. So number 14, I'm going to change it in a little bit. We'll come back and look at this later. Number 14 will be plus 2 test points. We'll call it enrichment. So it will go in the test category, which is the category that matters the most. So you'll get 2 bonus points. It'll be like getting 2 points on any test, getting added to some test, and doesn't matter what test. Just think in your mind you added 2 points to a test. If you can do this on a separate sheet of paper, we'll come back and talk about that in a minute. Let's look at number 13. Thirteen shouldn't be too hard. In fact, I'm not going to do the entire problem for you, but this is what happened. I want to just kind of talk about a composite figure. All right, there's my drawing. I'm just putting the units down here. 6, 2, 8, 4. All right, so basically I think all of us could find the volume of one of these rectangular prisms. So we just have to break it up and say, okay, we got 2 rectangular prisms. We're going to add the volumes of the 2 together. Now we have to do a little bit because the 6, remember, represents this entire piece. So if this whole thing is 6 and this part was 4, then I know that this part is 2. And so basically the volume of the entire thing is going to be the volume of the base of this first one, which is 2 times 4, times the height, which is 8. And then we come over here and do the same thing on this smaller one. And we've got 2 this way and 2 this way, you can see. So that's 2 times 2. Should have probably put that all in one thing. 2 times 2 for the base of this times 3. So when you get a composite figure, you simply basically break it up into 2 things you know how to find the volume of and find the volume of each and then add them back together. It's probably common sense, but it's okay. Let's talk about number 14. If you decide to do 14, you're going to do it on a separate sheet of paper and turn it in. You can turn it in anytime between now and Friday. So you don't have to turn it in on Wednesday. You can come back and talk to your friends about it. I will not tell you the answer though, but I will let you work together on it. How are we doing? Number 14. I'm going to redraw it. Don't put all of the dimensions in it yet. So do my best to draw this here. It's kind of hard. Something like that. All right. So actually we will draw the dimensions in. This is a 6. This is a 12. This is an 11. From here to here is 15. So what is this distance right here? Not counting that. What is that distance right there? Yes. 4. Very good. However, noticing that this is a 12 and this is perpendicular here. What is this distance right here? 12. So this is a 6 and a 6. Agreed? What is the radius of this circle? You don't know. Now, the answer key is wrong because they screwed this up. They should have changed this. I don't like this. This 15 probably should have been, what we need it to be, 17. Should have been a 17. But since it's not, we're going to make this an extra credit problem. So finding the volume of this guy is easy. It's finding the volume of the, whatever this thing is called here, part of a cylinder. That's the hard part. Agreed? So let's figure that out. I'm going to draw a circle here. It's a bad circle, but pretend with me. What you actually have, if this is the center of my circle, is you have something like this. Where this distance is 6, this is 6, and this is 4. And you have to find, as I'll stay consistent with my colors, you have to find the area of that green portion. To find the area of that green portion, you actually are going to need to know, let's put the 6s up here. You're actually going to need to know the radius here. We'll call that R. If we call this little piece here X, you know that R is equal to 4 plus X, right? So you could say equals 4 plus X or X plus 4 for the radius. So now you've got a right triangle here where you know that one of the legs is 6, one of the legs is X, and the radius is 4 plus X. And you should be able to set up the Pythagorean theorem and solve for X. If you can solve for X, then what you really need to do is find that angle there, don't you? Or eventually find the entire angle, because what do you need to do? This is part of a sector. You're going to want to take the area of a sector minus the area of a triangle. The area of the triangle is going to be fairly easy to find. The base is 12, and you solve for X, so you can find X, and then obviously you take 1/2. So you're going to need a little bit of trigonometry, I believe, to get this angle right here. I'm going to stop at that point in time because it's bonus, but that's how you can go about figuring out the actual volume then of the entire thing. Don't forget you're finding the volume of this. So the actual question is find the volume of the entire composite figure. But this is going to be the hard part of it, finding the area of that green piece that I've got there in the picture. Any questions? So you're going to have some time in class today to be working on this, and my homework today isn't going to take the whole time.